May I give a suggestion, Professor?
Of course, go for it.
I would like to create or suggest to create a WhatsApp group with all students. What do you think, or how can we do this group?
It's great idea. I will. Yeah, please. If you all can send your WhatsApp number if you're interested, of course. Chat of Google Meet. I will, and your name. I mean, I guess your name already appears with the message. Then I'll save it and I'll create a group. Thanks for the proposal, Marcus.
Let me try. I will send you my number and you receive with my name.
Perfect. So we have 9 people, I guess. We are 13. No, I have 11 now. Oh, I guess I'm counting myself, right? We have 10. With a little more.
I sent.
Thanks, Marcus. So Elisier is not here. Elisier Timóteo da Silva Sanha. Flávio is here. Flávio Soares. Frederico here. Lara here. Marcos is here. Patrick is here. Paulo Rodolfo Bufal. Not yet. And Renan. Do you guys have Renan and Paulo's contact? So just send them the link. Maybe they don't have the link for the lecture. Maybe I contact them in an email that they are not using, so they're not aware of the link. Oh, Renan is here, sorry. Paulo Bufão. I think only Paulo Bufão. Missing. So shall we start? It's 5 minutes going through. Maybe he will arrive soon. Yeah, so I'm gonna share my screen. So the idea of this lecture, I'm going to today Can you all see the screen?
Yes.
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 Oh, thanks. So we're gonna go through the course. I'm going to first give a brief presentation of myself. Then we're gonna go through the evaluation course, how the course is gonna be evaluated, how I'm going to score your scores in the end, and then going through a brief introduction to image storage. It'll be interesting for you guys to present yourself afterwards, after I present myself, so that I learn more what you guys doing, why you're interested in it, and image storage. If you don't feel comfortable speaking English, please feel free to speak Portuguese. I guess we all understand Portuguese. The idea of speaking English was because I feel more comfortable giving a lecture in English because it's more formal and I can express myself better in a lecture in English. In the end, I'm going to have a questionnaire. If most people prefer in Portuguese, then I'll switch to Portuguese. So you guys decide whichever option has the most interest, then will be decided by you, of course, please. You're the student. So, yeah. So I'm gonna give a brief description of my CV, of my experience, so that you know. I started undergraduate in the Federal University of Rio de Janeiro at Escola de Química, which is translated to chemical school. I did 1 year there. Then I went to the UK. I did my undergraduate in the Nottingham University in England. I got a degree in chemical engineering. I skipped the master because I found scholarship funding. So in the UK, if you have funding, you can do PhD even without undergraduate if the examiner decides to do PhD thesis with you. My thesis was on developing a tool called Oxford University Tool for Decision Organization. The idea is to have a framework where people will develop their decisions. I gave some tools like multi-criteria analysis, forecasting, and computational semantics for the computer to analyze, evaluate the decision, and give some input. Maybe we can go through in the future about this tool. It's not really relevant. Our work experience is I did an internship for the Energy and Climate Change branch at UNIDO, which is the United Nations Industrial Development Organization. I saw somebody joining. Hello, Rodrigo.
Opa.
Oh, yeah, I'm going through the lecture. Oh, Natalia, can you record, please? I forgot to ask.
To
This is
ask
not.
what I
Can
didn't
you
understand.
can you record?
Oh yeah, I
Record
already
the,
recording since the beginning. Yeah.
oh, thanks. Postdoctoral. I did a postdoc in energy planning program at PPE, which is a program for COP UFRGS in Rio de Janeiro. I did another postdoctorate in the Brazilian Nuclear Energy Commission, CNEM, also in Rio de Janeiro, in Botafogo. I did another postdoctoral degree at the International Institute for Applied System Analysis, IASA. So that's 8 years of postdoc. And now I'm a visiting professor at the Mechanical Engineering postgraduate program. It's actually graduate program in England. So if you're doing graduação, it's undergraduate, and pós-graduação is graduate. Just for you to not to confuse yourself. IASA is an International Institute for Applied Systems Analysis. It was founded in 1972 as a combination of US and the Soviet Union during the Cold War. The interest was for them to collaborate on research, mainly providing scenarios, future scenarios, which had the main intention to see what would happen if there was a third world war, nuclear war between US and Soviet Union, and this IASA after the Soviet Union collapse. Now IASA is a think tank that produces research on energy, water, ecosystems, systems analysis, risk, ecology, air quality, pollution, population, and transition to new technologies. So I had a CAPES scholarship for postdoc. I stayed there for 2 years. Then I stayed there for 1.5 half years, and I'm still a researcher for IASA. I'm a visiting professor at PROMEC because I am a researcher at IASA. So I'm keeping my position there, so I'm still working at IASA, teaching students at visiting professor at PROMEC. So the PROMEC, the grant that I have for this position is from UFRGS, and the objective is to increase the integration between the two organizations. So I'm a kind of ambassador to try to increase collaboration between two organizations. I made a presentation in the beginning of September or the end of August, where I showed the collaboration which is ongoing with PROMEC, which has already resulted in something like 8 to 10 scientific papers published. We're already working 4 papers, so we are publishing a lot of papers. My intention also is to help you that are interested to go to IASA and work there, also to research there, do it. And I'll give all the support that I can to get you guys there in IASA and continue the collaboration. And the interest of PROMEC in this print is a big coincidence because the application mentions that PROMEC is interested in energy storage. They mention energy storage 5 times in the justification why they want to be part of print. And that's good because the main research that I have been working on is energy storage. So it was a good coincidence. Yeah. So in PROMEC, most professors, of course, are from mechanical engineering because of mechanical postgraduate engineering, but I'm a chemical engineer. So I'm the second chemical engineer in PROMEC. And I am joining this energy and transport phenomenon. Yes, so I talked a lot about me. I would like you guys to give an overview of your curriculum, mentioning why you graduated in a master's degree, doctorate degree, work experience, what's your current research you're working on, projects, what's your particular interest in energy storage, and what
Can I
you're
ask you a
expecting.
question, Professor?
Go for it.
Are you living in Porto Alegre or are you in another place? Just virtual connected with.
I'm
Te falei que
living
agora que eu tenho
in
aula.
Porto Alegre. It's Rio Branco, Rua Cabral. It's 10 minutes from 15 minutes walking from the university. So I would prefer to be there if I could, because I always wanted to be a professor. I have been in this academic career for 10 years, and it's my first lecture as a professor. Not invited professor, but as a professor with a course. And so it's a shame that COVID is there and I can't. But it's convenient also because I'm at home, I'm it's not so bad. Alternative. So shall we start with Augusto and follow the order on the slide?
Okay, can I start?
Go for it.
Okay, so I am a master's student, mechanical engineer. My advisor is Professor Paulo Schneider, and I'm interested in the discipline due to relevance of the subject, especially with the growth of the renewable energies. And I hope to have an overview of the possibilities of energy storage and the challenges that the area has. Okay, I think it's that.
And what's your? Do you have a thesis title already, or?
Oh,
or
no, not yet. Not yet, no.
Is not related to energy storage, right?
In the moment, I don't know. No, I have don't decide yet, but maybe. I don't know.
Thank you. Guys, if you want to talk a little bit more, feel free. Or if you want to be brief, if you want to speak Portuguese also, because you don't feel comfortable with English, it's okay. Go for it. No problem. I'm gonna look if somebody arrived in the meeting. Okay, Conrado, do you wanna? Do you wanna continue? So Conrado is not online. He was online.
Maybe
Can you guys?
he dropped it.
Yeah, maybe. Can anyone ask him what happened?
Yes, I will.
Thanks, Natalia. So let's go for the next one. Next one is Eliezer. Eliezer. Here. No, Eliezer is not. Next one. Flávio Ricardo Soares de Souza. Soares.
Soares de Soares.
De Soares, desculpa.
Okay.
Sorry.
I prefer speak Portuguese at this moment.
Perfect.
Can I? Okay. And until the end of the course, I speak English.
Perfect.
But okay, I can speak Portuguese. Okay.
Yes, of course.
Minha formação eu sou aluno especial ainda não sou aluno regular, e eu tenho mais de 30 anos de experiência na área de petróleo e gás, especificamente na área de gás natural. Então agora uma nova fase aí, eu estou voltando para academia aí, né? E para renovar, me reciclar. E o meu interesse é na área de energias renováveis. E eu estou pensando em alguma coisa em usinas híbridas com biometano e biogás. Então, até como... E essa área de armazenamento de energia seria na parte de biometano, né? Alguma coisa nesse sentido aí, como complemento das energias intermitentes. Assim. É essa ideia que eu tenho de pesquisa. Ainda estou conversando com o professor Paulo Schneider e com a própria professora Adriane para desenvolver algum assunto nessa área. Assim. E a minha expectativa é realmente... Eu fiz a cadeira ano passado com o Paulo, o professor Paulo, e ele abordou alguma coisa nessa área de armazenamento, né? E a minha expectativa é aprimorar, aprofundar mais nesse assunto. A expectativa é muito boa. Era isso, acho. Obrigado.
Can I ask a question? Are you interested in gasification of biomass in order to produce syngas and then storing the syngas, or you're thinking more about anaerobic bio?
Anaerobic, sim, biogás por digestão anaeróbica, basicamente essa meu interesse, né?
Yeah, that's a very interesting topic, because there is the law of the gas law is going to be passed, right? So there will be a lot more regulation on using the infrastructure from Petrobras and being able to develop projects in this area and sell gas, buy gas, transport gas from one state to another, because there's no law on who's going to receive gas and who's going to pay.
Essa parte regulatória está bem incipiente, né? Principalmente no estado, tem alguma regulação estadual que está sendo desenvolvida, né? E aqui no estado também foi um dos pioneiros, tem alguns projetos já em operação, Mas em todo o país ela é ainda muito incipiente, né? Até para gás, com a ideia de gás de biometano tratado, né, para injetar na rede de distribuição e fazer o mix com gás natural, né? Então isso é ou em sistemas isolados também, né? Essa ideia que eu tenho para pesquisar e me
Yeah,
aprofundar.
we're looking at the energy storage aspect of biomethane. There is a very, very good alternative, which is literally have a storage tank which has enough storage for a day or maybe the weekly cycle for energy demands. And then what you can do, you can produce the biomethane with the biodigester, and you have a storage tank in between the biodigester and the turbine if you want to generate electricity or if you want to use for transport. And then you store, you have a constant production of biomethane because it's base load production. It doesn't stop, it's night and day. But you store this gas produced at night, and then you only generate during peak times, for example, to reduce the electricity tariffs from industry, commerce, or yeah. So that's a very good option, which I can present this in a future lecture. Yeah. So thanks so much, Flavio. Do you have anything else to?
No, thank you.
Julian,
Yeah, so,
I talked to Conrado. He said that he's facing some internet connection problems, but as soon as he can,
perfect.
He can come back. He will.
Awesome. Sometimes I can hear the request for invitation, but not realize. Just not realize that. So I'm going to constantly leave this screen to go to this screen to check if somebody is invited. No. Okay, so Flavio, in the end of this lecture, I'm going to give a very simple homework for you guys, which is I'm going to ask some questions. And it's very simple questions. What do you guys prefer to learn in this course? Well, if you prefer English, if you prefer Portuguese, very simple questions. And another question is proposals, which I haven't considered in this lecture. What else are you guys interested in learning? So I'm going to take notes about this biogas energy storage, and I'll add into the. This is the first time I'll give lectures. I never prepared lectures before, so I'm gonna prepare what you guys are interested, right? There's no point in doing something different. Biogas and storage. Okay, so next, Frederico. Frederico there? Frederico is here. Hi, Frederico. Are you there? I can hear you. Maybe he's also having connection problems. So let's go to Lara. Lara, are you there?
Yes, I am. So I'm an energy engineer with my master's degree in mechanical engineering. And during my master, actually, I worked with coal-fired power plants. So now I'm not sure about my thesis, and probably I'm going to work with renewable energies and energy transition. I don't know for sure. So I'm here to learn everything I can. And that's it, basically.
Thank you, Lara. Marcos?
Hello, my name is Marcos. I am mechanical engineer, and I did some courses that I will explain. I did energy management at UFRGS in 2011 with Paul Schneider. A postgraduate title, I think. I did a master's degree in University of Salamanca in Spain in renewable energy and energetic efficiency. I did an MBA course in project management too. And at this moment, I'm doing this master program at UFRGS. I am a special student like other colleagues, and I don't have projects to present in the future, but this area is very interesting to me to develop my project about storage, for example. And I don't have a professor to do it.
Perfect, Marcus. Can you explain me what is a specific ESP student?
Okay,
Because,
no problem. We have a kind of I don't know how to explain in English. We have an edital in Portuguese to complete to be a regular student at UFRGS. And when you didn't arrive the number of points necessary to do it, you can wait 1 year more to achieve these points, and you can course some disciplines like a special student.
Okay. Very good. We have
I am in this situation at this moment.
Well, good luck. I'm sure you'll manage to become. You want to become a master student or a PhD student?
I'm sorry, I cannot understand.
So you want to become from a special student? You want to become a master's or a PhD or a doctor?
I'm waiting the new edital to apply other time to a master's degree, because at UFRGS it's impossible to
skip the PhD, to skip the master.
Yeah, to skip the master's. You need to do the master's to go to the doctor level.
Perfect. Thanks so much, Marcos. So,
Julian,
Patrick?
Okay.
Julian, just to tell you, Frederico said that he's listening the class, but his microphone didn't work.
Yeah, can you hear me now?
Okay,
Maybe?
now we can hear,
perfect.
yes.
After some
Yeah, we can hear you
configuration,
now.
it's working. So,
Hi, Federico.
hi, it's a pleasure to be here. I'm Fred, actually. You can call me Fred, everybody.
Hi, Fred.
Always Fred. And I'm a mechanical engineer from UFRGS as well. I have a MBA as well in business management from Unicinos here, and have some experience of 12 years at Steel Ferramentas in São Leopoldo. We developed two-strokes small machines like chainsaws for low-emission markets, for example, USA and Europe. And I'm as well a special student. This is my third subject. And so right now at Steel, we see, for example, some change in the market. So two-strokes machines, of course, we use gasoline, but we see a growth in the last years of batteries, for example. And I believe we will change this market. I don't believe that gasoline will be forever here. But at least for the two-strokes engines, we still have, mainly for professional market. For hobby users, not so much anymore. But my intention here is to be prepared for this future and to have an overview of all the storage types and learn with it. I'm very interested in renewable energies, and that's my objective here. And I will try to be a master student. I believe we will have this opportunity at the end of this year. Maybe we will release a new edital in some weeks and try to be a master student. And that's it.
Thank you, Frederico. Fred, sorry. So let me just ask again. So you are working at a company, right? Unicinos and? No.
Still, actually. Still.
How do you... S-T?
S-T-I-H-L. It's a company. It's known for the orange color of the machines. You can see those machines.
So you produce, for example, motorcycles, boats, and for those boats, engines.
Yeah,
ones that you need oil. You need to mix oil with gasoline, right?
Yeah, for engines like small engines like chainsaws, power tools, not bicycles, but small ones, small tools.
And what's the benefit of having a two-cycle motor? I never studied this. Can you briefly give what's the benefit of having such type of machinery that you have?
Yeah, the advantage is that you have a lot of power. Imagine that one user have to go through a forest where you don't have any kind of energy there, and they need a lot of power to cut a tree, for example. And then you have a lot of power with a less weight. For example, if you have just 1 liter of gasoline, you can work for some hours. Right now, if you use batteries, you would not be able to do that. You would need like 20 small batteries, and you would not have such power that you need. So for professional market, but of course, if you are at home, you just want to cut something small, batteries work very well. But right now, for professional users, we still have 2-stroke engines. But we are also having a lot of regulations last years. For example, in California or Europe, you have emission regulations each year tighter. And that's why I have my job, because I do cylinders for low emissions machines, 2-stroke machines.
Okay, thank you. I guess it also has to do with the size of the equipment is small, so you want to make it as powerful as possible, right? Because you don't have gains in scale. Because the machine is already big enough in order not to need these cycles. Is that maybe the reason?
Yeah, this is right. This is right. Since you have to carry this machine with your hands,
it has to be small.
Okay. Yeah, it needs to be small.
Perfect. What does Müller means in Portuguese? Translate.
In Portuguese, actually, this is a German name. It means people that in the past used to have these windmills.
Windmills.
Yeah, windmills.
This is interesting.
Yeah, all German names were always professions, and that's what was the profession of my I don't know how do we say in English.
Ancestors.
Ancestors, exactly.
Thank you, Frederick. Yeah.
Thank you.
So Marcus already. Now Patrick. Patrick, are you
Hello?
there?
Can you hear me?
Hi, Patrick. Yes. Yeah.
Okay, I have a master's course in mechanical engineering. Of course, I am a mechanical engineering, and now I'm taking my PhD course. In my master's, I studied the fluid and structure interaction, and in my results, I showed that there is a way to produce energy from the interaction between circular cylinders and the flow. In this case, I studied circular cylinders and used air as the work fluid. And in my doctorate, the idea is to improve the way that we are generating energy and do the project of new gadgets and new devices to use the energy from the air or from the water to generate energy in small quantities. Actually, there is a expression energy harvesting for this generation of energy.
Oh, thank you, Patrick. Do you mean you're developing a new turbine?
It's not a new turbine, but we use the vortex sharing to produce energy.
Is that similar to the Tesla turbine?
Yeah, it's similar, but it's not equal, you know. It's similar, but it's not the same.
I was very interested in Tesla turbine. I came across, and it's supposed to have the highest efficiency possible, right? But the problem is that it just becomes not practical because it's too expensive. Is that the case?
No. The energy harvesting idea is use energy from the air that will be wasted in other case. So the idea is use an energy that will be unused to generate small quantities of energy.
Is that with thermal energy, thermal heat, so thermal source, or is it just wind turbine?
No, the kinetic energy from the air or the water. For now is from the air, but the idea is use the water also.
Is that the horizontal axis?
Yes.
I'm trying to picture here.
Yes, in my master course, we use the cylinders in horizontal.
Okay. Yeah, now I understand. Sorry, I didn't really understand. Now I understand. Perfect. Well, good luck with that.
Thank you.
It's a lot of work. Do you have anything else you want to share?
No, for now, I'm done.
Perfect. So Paulo. Oh, Paulo. I think Paulo is not here. Let's have a look. Paulo, where's Paulo? No, Paulo is not here. So let's go to Hannah. Hi, Hannah. How are you? Can't hear you.
He's saying that he's going to introduce himself in English, but in the text because his microphone is not good. Is that okay?
That's completely fine. I can read, hopefully. So look. I'll do it in English. As you requested, playing test. It's okay. Can you write? And you can take your time writing. And then we'll go back to you because we might as well just keep going. I'm Renan Becker, environmental technician at IFRS, Federal Institute of Rio Grande do Sul, and bachelor as energy engineer at State University of Rio Grande do Sul. And I am PROMEC for a master's degree with a CNPq scholarship. Perfect. Thanks so much. And if you want to keep writing, I'll go back to you. Experience with foreign country in Portugal. And I made the amazing University of Coimbra for a year. Very nice. Very nice. Please feel free to write more. I'll read your comments after we finish with the voluntary participants. So, Natalia?
Hi.
You wanna?
I'm like Hannah. I'm an energy engineer from UFRGS, and I made my master degree in energy planning at USP, and now I'm doing my doctor's at PROMEC. My advisor is Paulo Schneider, and my co-advisor is Julian Hunt, that is our professor right now. And I wanted to learn more about energy storage because I have been searching and studying renewable energy for more than 10 years. And then I realized that without energy storage, it's not going to be so much viable and feasible for us to have a lot of energy sources, renewable energy sources in our Brazilian matrices. So that's it, I think. That's it.
Thanks so much, Natalia. Rodrigo?
Oi, eu vou falar em português, tá?
Claro.
Sou meio tímido, já me atrapalha em português, imagina só tentando falar inglês ainda. Eu sou engenheiro mecânico. Eu fiz mestrado pela UFRGS, né, e agora estou fazendo doutorado também pela UFRGS, né. A minha ideia de trabalho, meu tema de doutorado vai ser modelagem de PLD horário, né, e montagem de portfólio de energia. A princípio, são esses temas que eu estou trabalhando, né. E vamos ver o que mais surge, né, na esteira aí desses temas, né. Mas a princípio o principal é o PLD horário e portfólio de energia, né, montar portfólios de energia em cima desses modelos. O que mais? Hoje, atualmente eu trabalho na CE, que é a Companhia Estadual de Distribuição de Energia aqui no Rio Grande do Sul, né, por enquanto do estado, né, e trabalho na parte de manutenção, né, lá, né, e o que mais? Eu acho muito interessante essa questão também de armazenamento de energia, né? Na verdade, quando eu entrei no doutorado, até a Natália entrou junto também, né? A gente ia trabalhar no assunto de armazenamento de energia, né? E acabou que o projeto de pesquisa que estava vinculado acabou não saindo e tal, e esse assunto acabou ficando né? Ficou de escanteio, né? E então... E também a ideia, que eu acho que vai contribuir também essa cadeira, essa questão também de, né, ela vai também falar sobre modelagem de energia, né, então achei bem interessante também, né, acho que vai contribuir bastante para o tema do doutorado. E acho que é isso, né. Desculpa se eu gaguejei muito aí, mas como eu falei, falar em público, né, meu...
Thanks for sharing your interests and your experience, and welcome to the lecture and whatever you have time and interest. Very very nice to have you guys that are joining just to get some extra knowledge on the topic. Please feel free to participate as the other students, and please feel free to send the research proposal if you want me to have a look at it. If not, of course, don't send, because you're not going to impact your score. Of course, you have no score. But I am available here for you to, if you want. So there is another. Do you have anything else to say, Rodrigo?
Não, só isso.
Awesome. Thanks so much. Giovanni? Is Giovanni there?
Yes.
Hello, Giovanni.
So I'm Giovanni. I did my master degree in University of Caxias do Sul. It's a city near to Porto Alegre, about 2 hours. I researched about dual fuel combustion in a compression ignition engine, operating with ethanol and diesel fuel. And now I'm in the second year of the PhD, and I'm studying homogeneous compression ignition engine. It's another kind of engine operating with ethanol as well, and ethanol with high concentration of water. And I'm here in this discipline to learn more about energy storage. I believe that's a very interesting topic. And as Frederico said, the future of internal combustion engines is very uncertain. And I would like to learn new things. And I think that's it.
Thanks so much, Giovanni. Can I ask a question? So the idea is to burn diesel and ethanol at the same time, or having a hybrid?
Yes, in my master's degree, the idea is to replace diesel fuel to ethanol. But now I'm working a different engine that operates only with ethanol, and ethanol with high concentrations of water. It's a compression ignition engine operating with ethanol.
Yeah, so compression engines have more higher efficiency, right? So the idea, I guess, is to try to increase the efficiency of ethanol combustion by adding a little bit of diesel, right?
Yes. The idea now in my PhD is to use a different combustion mode, call it homogeneous charge compression ignition engine. It's more efficient than compression ignition engines. The NOx emissions is very low and can probably meet the legislations. And the great opportunity here is to use this type of engine that's called low temperature combustion mode, coupled to a hybrid automobile, something like this. So
very interesting. What's the share of the share of ethanol and diesel by volume that you have to add to the fuel tank for it to operate?
The maximum replacement that we achieved was about 80%, 85%.
You mean 80% of ethanol, 20% of diesel, right?
Yes.
That's very impressive.
And the benefit is we can reduce the NOx emissions, CO2 emissions, and of course reduce the dependence of fossil fuels. That's the main goal.
You can use biodiesel also, so then you go 100% sustainable, right? Also, so
yes.
Yeah, I'm going to talk a lot about this, the changes that are going to happen in the future, and one of the topics is that in 2001, the whole world was crazy about biofuels, and Brazil had huge kind of present in their hands, which was ethanol. Unfortunately, at precisely the same time that this biofuels was considered by every country in the world, we decided to focus on oil, right, instead of investing in ethanol industry. So the ethanol industry reduced a lot, and now the whole world is thinking about hydrogen, and hydrogen is a lot more expensive and a lot more complicated than biofuels. Biofuels in Brazil is competitive with oil today. In order to make hydrogen competitive with fuels, with fossil fuels, with oil, gasoline, it's gonna take at least 50 years. It might not ever be competitive, even with all the investments that they put in the industry. But the idea is to become sustainable. So we lost a battle, but we still have a lot of sunshine, a lot of water, a lot of land, which we can still make good use with good policies and go back and start selling some biofuels to Brazil and for the rest of the world. My main concern is that the major companies decided already that in 10 years they will stop building combustion engines. For example, Volkswagen, all the European, American, Chinese, Korean industries, and we don't have a capacity for producing these engines. So we'll have to use hydrogen, because one of the alternatives is if Brazil invests a lot of money and start their own automotive industry, but the combustion engine is most likely going to finish in 20, 30 years. I say that as of course, as a prospect of a scenario in the future. Of course, the world nowadays is becoming much more competitive, and there are a lot of other players which might want to sell combustion engines for developing countries. For example, China. China might want to, get some extra bucks selling some motors, and they have the capacity and they can invest, and then they can start selling to Brazil. But the decisions that are already going in now is that the combustion engine is going to be gone. So the biofuels industry had its chance, and it's going to be difficult for it to really happen in the future. Brazil, like countries in tropical areas, have a huge benefit for biofuels, but we have to make our own investment. No one is going to invest to make markets for us, right? So we have to create policies. I'm going to have a lecture on this, go in more detail, but it's interesting that you're here and that you might be interested in this lecture.
Yes, of course. Thank you.
So let's go back to Hannah. Hannah had my work with Professor Snyder, and I'll start soon as with you, Professor Julian, in the energy storage field. I have interest in pump-back hydroelectric dams and a lot of storage methods to use with solar wind energy produced the main hours of demand. Exactly, combustion engine for everyday vehicle will not last long. Thanks for your comments, Hannah. If anyone has any other comments and don't want to talk, you just want to write, please write. I'm going to save the telephone numbers here in order to not miss the telephone numbers. All right, thanks so much. Anyone has any other comments, questions? No? Okay, thanks so much, guys. I'm going to start the second part of the lecture, which is talk about the course, right? So in the course, I'm going to introduce energy storage. We're going to go through the energy storage technologies, hydropower pump storage, other mechanical energy storage technologies, batteries, hydrogen, thermal energy storage, other energy storages generally, and technology innovation, so new materials and other types of energy storage which are becoming relevant. I'm going to teach you a message, which is a tool for long-term energy planning, and of course we're going to use energy storage in the scenarios. The idea is to, for example, be able to estimate to create optimum scenario for the Brazilian energy matrix. How we invest in hydrogen, solar power, wind power, hydropower, biomass, and it can go as much detail as you want. Of course, I'm just going to go through some tutorials because these models are not very straightforward. But if you're interested, this part of the course is 100% relevant to IASA. So if you guys want to go to Austria, have a good time, get a scholarship there, do some serious research that has big impact in the world. This is the topic which is the most relevant for the collaboration between PROMEC and IASA, and it's interesting too. There's a few people that work with this, which is Robert Sheffer. There is in PPE. There is another Emilio works with a different tool, which is osmosis, but is also trying to do energy planning. There are some people in Minas Gerais which are doing work on long-term energy planning. Of course, EPE have their own tool. The Ministry of Mine and Energy has several tools which have been developed in the past. The CEPEL has their own tool. Eletrobras used to be Eletrobras used to be ANEEL, ONS, and every organ of the energy sector. So they all also have their own tools, which are actually used nowadays to do the planning. But I'm not going to talk about them. I'm going to talk about the other tool, and message is great, and it's very competitive and exists for 60 years now. And there's a lot of people working and developing, improving the tool. Actually, I'm one of them, developing, improving the tool. So yeah, we're gonna go through that in the future. Energy storage regulation. We're gonna talk a little bit about regulation in other countries, regulation in Brazil, options for Brazil, why it works, how it works, how it should work, the proposals. So there is currently this time today. There is I forgot even in Portuguese the name. It's a consulta pública of energy storage regulations. So they have proposed some energy storage regulations, and there are consulta públicas already. So people are talking a lot about this, and it's a very important issue. So I'm going to keep you up to date. Economic aspect of energy storage, when it makes sense to invest in energy storage. Let's say if you want to replace a diesel generator in a supermarket, instead of generating electricity with diesel, you store energy off peak and generate during peak hours, which nowadays is the most cost competitive alternative. Or there is, if you are working in a big energy company, you want to build large scale batteries for optimizing energy transmission, or you want to generate electricity during peak times using the changes in energy costs with the new PLD, new cost of energy, which will start in 2021. So I'm going to address these topics also. And technology innovation, for example, patents. If you want me to go through how to write a patent, how to submit a patent to INPE. Sorry, it's not INPE, it's INPE. INPE, yeah. INPE in Rio de Janeiro. You can do it online nowadays. It costs literally 100, 200, 250 reals for you to submit. It takes something like 3,000 reals for the whole process, but then you have to pay some fees. I have submitted some patents. I haven't gone through the whole process, but I have knowledge. So if you guys want me to go through that. So I'm gonna, in the end of the lecture, I'm gonna give a list of 30 topics, and I ask you to rank from 1 to 10, and then I'll focus on the niches that interest you the most. Today, I'm gonna talk. So it's not course summary, sorry, it's lecture summary. Today I'm going to talk about course evaluation criteria. So how you guys going to be evaluated, how well you perform in this course. I'm going to talk about R&D, ANEL R&D, which is PID in Portuguese, which is research and development. I'm going to give an introduction to energy storage, needs for energy storage, the electrification of the transport sector, the heating sector, and talk about different alternatives for energy storage, talk about the methodology, what is energy storage, how it works, and give some example of technologies. So the bullet 7 is alternatives to energy storage. So if you don't want to store energy, what else can you do to resolve your problem, right? Sorry, it wasn't clear that. A student preference, feedback, and then conclude that. So course evaluation is literally, I would like you guys to write an R&D project. So the first examination will be for you to write 8 to 10 pages. Maybe you can write more if you feel like writing more. I don't mind reading all your pages that you write. If you want my feedback on the project, it's interesting for you to write. If you want to be researchers, you need to look for funding to develop your research. In order to become an academic researcher, you need funding. So apart from focusing on energy storage, we're also giving some capacity for project development. So the project, I'm going to go through how I'm expecting you to write this annual project. The second examination is a presentation. So 10 minutes presentation. It could be a present. I'm going to go through more details in the next slide on the presentation. And then the last one is a report, which is kind of like a result of the project. So first you make a project proposal, you present the ideas as if you're selling it, and then you write a report of the results of the research that you were intended to develop. But it can be short, it can be long. Doesn't make any difference if you write something less than 8 pages. So 3 pages, maybe I can consider, oh my God, no, this is not enough, for course 22 lectures, so that will impact your score. But if you write from between 8 to 10, that's enough to get an A, for example. I'm not strict. I'm not planning to give B or C to anyone. Just if you really want, I'll give you that. But if not, I'm happy to hear your opinions and to help you to improve your project skills and your knowledge on energy storage. You guys have any questions? I'll go through the whole course evaluation and then I'll ask you what you guys think about, any suggestions, and my first time I'm doing this, so it will be interesting to you probably know better than me. When I did my PhD in Oxford University, I did 4 years PhD. I had no lectures. I didn't do masters, so I did an undergrad and then PhD, no lectures. So you have much more experience than I have, so you have a lot more to contribute. I'm looking forward to your feedback. So ANEL R&D has a lot of money, something like an average $500,000 per year. It's a lot of money invested. It's a big pool of money, so it makes sense for us to use this framework for the course proposal, because you also learn about ANEL R&D project, and is a huge market for research and development. The types of R&D projects, which is also the type of projects that you guys can produce, are basic research, applied research. So basic research is something like you want to propose a new battery, a new component for a battery, a new strategy for thermal energy storage. It doesn't need to be so new. Also, you can also use a case study for one technology in one country and apply the same technology in Brazil. Just change the temperature. It can't be too similar, of course. It has to have some aspects of innovation, because if not, that ANEL would not approve the project. It has to have some aspect of innovation. Technology is research and development, right? So you can just copy and paste somebody else's work. Applied research would be literally you can have a system which requires energy storage, and then you have you show the system without energy storage, how it operates, and then you propose any storage solution, and then you show how it will improve the system. Any aspect, applied research, just go the calculations, show some figures, great. Experimental development is really, if you guys want to go to the lab and develop something and you want my feedback, it's a lot of work. I won't provide you a lab, but if you guys want to, go for it. I was mentioning to Natalia that yesterday I wanted to see if I can make a steam balloon fly, and I got a pressure pan. I heated up. It was producing steam, and I put there, and it floated a little bit. And that's experiment, right? I looked in Google, YouTube, and tried to find if somebody did it, if it's possible, and I couldn't find. So I tried myself. You know, please be careful not to burn yourself or damage yourself, but something like experiment. You can feel free to do an experiment. Prototype is a little bit more complicated. You need, investment money to make a prototype. Frederico, Fred has a company. So if you want to do an experiment, prototype of an energy storage product, wow, that's gonna be amazing. Of course, you can't get more than A, but feel free to go for it. It'll be very interesting. You present it, and everyone's gonna be very happy to see your presentation. Pilot project, then it becomes like a large-scale solution. Maybe it's a small-scale solution. Maybe you want to do. I think Rodrigo is working on a thermal energy storage device, which he produced some calculations. He developed computational fluid dynamic modeling for a prototype. This would be applied research, but if you actually want to do a pilot project for that, you can do it, and that would be great also. Market insertion can be literally thinking of ways in order to make people invest in energy storage. If you are more interested in the marketing side, if you're not really into the technological details, if you want to propose a solution, for example, batteries. I wanna sell batteries for hospitals that generate electricity during peak times with generators. If you do the equations and you show that the hospital will make money if they throw away their diesel generators and they use. Hospitals have diesel generators in case you have a blackout, in case you don't have electricity for days. So forget about the hospital example. Let's say an industry where they have diesel or a shopping center, which have diesel generators for peak generation. Instead of having diesel generators, you can have a battery, and if you make the calculations and you prove that they make money and convince me, you get an A, right? So this is market insertion. So it's very broad, which feel free. Produce your project. It will be very interesting to see. This is the division of energy projects. So most of them are applied research. Then you have experimental development, 30%. So these are the existing projects since the start of the program until today. So that's the share of type of projects that exist. This is not the money going to the project, it's the number of projects. So prototype, this is the pilot project, and this is market. So just for you to have an idea, but don't use this as an example that what you should do. You do what you feel like you should do. So assignment structure, the first task, the first report is an R&D project proposal for energy storage. So the topic has to be energy storage. So you have to select a company which is in the energy market, which you think will be interested on this. Of course, you're not going to send this to them. You're going to send it to me to analyze. The structure is introduction, methodology. You have to talk about the originality of the proposal, the applicability, the relevance. You have to show a schedule for the project. You have to show the budget and the references for the proposal. So this structure is in the R&D NL manual, which I'm going to send you the link. You can go there and read exactly this structure. And if you have a question, please come to me and ask. If you guys want a template, I can send you a template. I'll send you a template. So the second one is the presentation. 10 minutes presentation. So the presentation can be either you trying to sell your project to the company. So you say, okay, I have a project. So basically presenting this. So you can present this, or you can present the results. So you can either present this or this. Be different, of course. So the number 1 and number 3 should be different, but of course in the same area, the same topic. It's the report. So the third one is the report. You're gonna publish you're gonna write 8 to 10 pages, talking about the project, what you did, how you went, and the results. You just show, okay, what I was intended to do is this is what I got. Write the conclusions, discussions, if it makes sense, if it doesn't, and all that. So I give more details on the evaluation criteria. On the report 1, I'm going to evaluate project or product that you're going to develop. Description, I'm going to evaluate the project images. So you're going to get points for images. Originality, applicability, relevance, and cost reasonability. So the idea is that I'm going to be kind of the company or ANEL analyzing the project to see if it's acceptable project. And I'm going to use the same criteria that they use to see if it's a good project. Then the presentation, I'm going to give the same scores for the structure of the presentation, the content, the fact that you keep the presentation between 9 and 10 minutes. So if you take 15 minutes, that's going to count as a negative for your presentation. If you presented 5 minutes, that's going to count as negative also. The clarity of the presentation, of how you present. If you're not comfortable with English and you want to present in Portuguese, feel free to present in Portuguese. I'm not going to correct your English, so if you make 1,000 English mistakes, that will not count. But at least the presentation has to people has to kind of understand what you're trying to say. Project images, also images, please. So we're talking about energy storage, images for the energy storage technology that you guys talking about. Doesn't need to be the technology, can be also the market insertion and any image that is relevant to the project. Report of ANEL. Also, I will analyze the structure, detailed project description, detailed equations. So please put the equations that you use. Anything, if you don't have equations, don't need to put equations. So that this criteria will not be relevant. Of course, have common sense. If you're talking about a market insertion, I'm not going to worry so much about equations. Detailed results, description about the project, and these are the links for the ANEL manual and the updated resolutions for how to produce an energy project. Do you guys have any questions about the structure, about the examination? Are you comfortable with this? Do you like it? Do you think it's a good idea? Do you not like it?
Professor, os trabalhos são individuais?
Individuais.
Okay.
I'm a little worried about the results you should present. How complete do you expect the results should be, considering the time you have to prepare the work?
Yeah, so 8 pages. It's the minimum required to get an A. Let's say 8 pages with double space. You have to kind of have an example of the issue. Let me give you an example. For example, if you wanna show that somebody is interested to sell batteries for a supermarket or a shopping center, you need to show the equations. You show an image of a battery. You show the cost of the battery, the cost of the diesel. You have a column, a table showing the cost, the details, the operation cost, and investment cost, operation cost, and then the results will maybe they will come up as the battery is cheaper. So what's the goal of the battery? You literally need to generate electricity for 3 hours, which is the peak hours, and then you see the cost of energy for peak hour. You see the cost of energy outside peak hours. You need to buy the energy off peak, and you need to sell the energy off peak hour. Then you come up with a value, which is it doesn't need to go too much in detail, saying the return investment return rate. You can just be, this is the investment, it gets paid in 2-3 years, or you can compare the cost, investment costs and operational costs, and come up with a conclusion that's cheaper. Doesn't need to be so much. 8 pages. The 8 pages you wouldn't be able to develop a very sophisticated work project. It's just to show that you have some knowledge on energy storage, that you wrote a report with a structure. It doesn't need to go so much into details. You can focus on one aspect. For example, battery. If you wanna, for example, know if the battery that you have is enough to store energy for your solar power, and then you can put the solar power there. It doesn't matter how much it costs, how difficult it is to put there. You generate some solar energy, and then you want to decide to only rely on solar energy in a day, how much battery capacity you need, and then you're trying to find the optimum battery capacity for your house, and then you make some calculations how much you need to store energy for your solar panels. That's also a project. So any project will have 22 lectures to discuss. You can talk to me about your project interests, and I can help you with developing the projects. I can answer your questions. If you have doubts on the methodology, you can send it to me after. Say, Julian, can you have a look at it? Is that okay? And I'll say, yeah, it's okay. And then I can give you some suggestions to improve. And then it's good. It's not like I'm going to give you the task now and you guys will come back to me in 5 and 6 weeks with the project. No, we can talk about it. We can discuss, and I'm open to answer your questions. I'm here to help you guys. I'm not here to not help you. So, did I answer your question? Lara?
Yes, you did. Thank you.
Thanks. Any other questions? Right. So another aspect which I thought it's interesting, just for you guys to be able to be free and more comfortable with sharing your ideas, and that we or no one from the lecture will literally use your project, nor me or any other students, I would like you to guys just to write this confidentially agreement, which would literally it just says that the students and the professor agree not to reproduce or expose to others their ideas and projects developed and presented by other students without their consent. So, for example, if somebody presents a project or idea, no one's going to steal your idea. Maybe they will steal your idea, and there's not much we can do about it. But at least we have a contract here that's explicitly say that we are not going to share with no one, and we're not going to use the project of ideas. Or if somebody's interested in the idea, they can come to you and say, "Oh, by the way, this is an interesting idea. Shall we develop together projects, or can I develop a project on this? Do you mind?" And then maybe they say, "Yeah, of course you can, but please invite me to the project." Things like this. So Brazil has intellectual laws, and they're not very strict. In the patents in Brazil, they are very blurry subjects. For example, if you present a project, somebody can take it and use it and do it themselves. You know, that happens all the time. It happened to me also once, and it's okay. It happens, but in Brazil, it's difficult to protect your intellectual property. So what I would like to suggest is that we write this. It's just certification that we are okay with it, and if not everyone signs and somebody's not comfortable with sharing this, hey, their idea, they can present the idea only to me, for example, or they can the person that's not happy to present maybe uses himself for the presentation of the other students because he's not willing to keep a confidential agreement. What do you guys think about this? I'll be happy to hear your feedback. I just want to make sure that no one steals your ideas because we are working with intellectual property here. We're working about R&D. And it's a sensible issue, right? And I don't want anyone to be sad in the future. Any feedback?
Julian, I think this is very interesting. Congratulations on this. It's very professional.
Thanks. Who say that?
Me, Conrado.
Oh, Conrado.
Finally, I can get here.
So you're here. Thanks for your feedback. Yeah, this is not guarantee that the other person can or cannot do anything. This is just something that can add to the person's arguments, you know, for going against somebody using somebody's idea. I'm sure no one's gonna use somebody's idea. Is friendly here. Everyone know each other, and you know, like there's no point in not inviting somebody to do a research project. The person that had the idea, which is willing to work, which is interested in the subject. Of course, that's is not gonna happen, but it's just something to certify to make people more confident and comfortable to share their ideas. So I'm gonna send you this. Hope that everyone signs. If somebody doesn't sign, it's okay. It's fine. We can work around it. And yeah, let's go. Let's keep going. So introduction to energy storage. So why is energy storage important? I'm gonna talk about the needs for energy storage. So let me have a look. I have half an hour. Are you guys okay with time? Am I going too fast or too slow? I guess I'm going too slow. So, okay, so half an hour. I'll try to keep in half an hour. There's some. If I don't have time, I'll just. Now starts the lecture, right? Into energy. Needs for energy storage. Why is energy storage so important? So these are the topics. I might as well just jump to the details. So in the past, why energy storage was not important in the past? Why energy storage is so important now and was not important? Because in the past, we use coal, gas, nuclear, hydro, power, geothermal, and biomass, which all have their own energy storage solutions within them. For example, coal, the energy storage for coal is coal because coal is a fuel. Coal, the energy is inside coal. You have to burn it. So you have to change the molecule. You have to transform hydrocarbons in water and CO2. They don't need energy storage solution because they are the energy storage. Coal is an energy carrier, so there is no need for energy storage. The coal is an inflexible energy storage technology. It's so expensive that you want to operate a coal power plant as baseload as much as you can. But that doesn't change the fact that you can use coal to produce syngas, for example, and gasify the coal in case you need. It's just going to increase maybe twice the price of energy generation from coal, but it will allow you to produce electricity during peak times with flexibility. For example, in the Second World War, Germany didn't have oil; they have coal, and they turned coal into oil. They turned coal into gas. They filled their tanks with gasoline, diesel, and hydrocarbons produced from coal. They produce even butter from coal. So if you have coal, you have a lot of energy. You can solve your energy needs. But of course, nowadays coal is not a very good technology because it emits CO2. Gas, the same. Gas has energy storage because it's an energy carrier. The gas is the energy storage itself. You only get the energy from gas if you burn it. So you can decide when you burn the gas, and then the energy storage of gas is the gas. Nuclear is the same, it's a fuel. Uranium is a fuel, which runs a nuclear power plant. And also you can dispatch whenever you want. You turn on the nuclear power plant. It takes 2-3 days for the nuclear power plant to be fully operational. It's also a base load energy storage generation plant, but the energy storage is the uranium. So you can generate energy when you store uranium. Hydropower. In the past, hydropower wasn't such a big issue for environmental reasons, so reservoirs were built in order to make sure they always had water to generate power when you need it. Of course, you have a drought and you stays several years without raining, then you have some issues. This is one of the reasons why people stopped using hydropower in the US, and it wasn't really due to environmental issues, it was more due to security of supply. And of course, if you burn coal, you can control the whole industry, buying from one country from another, and manage the whole industry, which makes money. You can buy and sell coal. Yeah, there are a lot of reasons why different countries choose different energy technologies. Hydropower also has energy storage because they have reservoirs, and the reservoirs can guarantee that you can generate energy whenever you want. Geothermal also, you have an unlimited supply of heat in the crust of the earth. You design your plant as you want. Maybe you want a plant that provides baseload energy. Maybe you want a plant that provides peak generation. They have different designs. Of course, for geothermal, it's more convenient to have base load. Thankfully, you have several other alternatives to produce peak generation. So this joins the mix. Biomass, as I mentioned, biomass is also energy storage because it's the energy stored within the biomass, similar to coal, gas, and other fuels. So energy storage wasn't an issue. Today, why today is such a big issue? Today is a big issue because you have solar renewable energy technologies, which are intermittent, unpredictable, And you can store, for example, the sun. You can store the sun, solar energy. You can store the heat produced from solar energy, but it's not full energy. And then we will talk about thermal energy storage. Wind, you can't store wind. Unfortunately, our president said that we can't store wind. No, we can't store wind. You can store the energy produced from wind power. Hydro energy also, and store the time. And another issue currently that we have is that new hydropower plants, due to environmental concerns and probably a lot of lobbying from companies that want to sell you energy storage solutions, they don't have storage. They just generate as much water flows in the river. They have to maintain the river, the reservoir level in order to have few impacts in the environment. And then you have run of the river plants, which is the case in Brazil nowadays. Another benefit for energy storage, apart from the insertion of renewable energies, is the fact that you optimize your transmission grid. One way of optimizing is to storing energy close to intermittent energy sources. So you provide storage for their generation, and then the transmission line that will transmit energy from these plants to the final customers. These transmission lines will not need to be the maximum generation capacity of this plant. It could be something like 70% of the capacity, 50% of the capacity, depending on their capacity factors and depending on the capacity, the storage capacity of your storage solution. But it could reduce the cost of the transmission line. Another reason, which is particularly interesting in Brazil, is to store energy close to the demand. For example, if you build a lot of batteries or pump storage plants in São Paulo, what happens is that in Brazil, you have a huge transmission line system. It's one of the biggest in the world. It costs something like $400 billion reals. It's very, very expensive. And at night, it literally sleeps. The capacity of all these transmission lines kind of reduce to a half. Some of them doesn't. For example, Belo Monte is a run of the river plant, so they'll keep generating 100% capacity during the wet period when the flow is very high. So this won't reduce at night, but other ones that have storage capacity, other plants, for example, thermoelectric power plants, other solutions which you can control, they will stop producing energy, and this transmission line will stop operating because you don't have demand, because you have to generate electricity at the same time it consumes. You don't have consumption, you won't transmit, you won't generate. But if you produce an energy storage solution close to São Paulo, for example, at night when the whole grid would be sleeping, you can use it to store energy close to the demand in São Paulo. So then the next day you don't need to use the congested lines, which are very busy because there's a lot of energy to be transmitted to São Paulo. And then the energy is there, close, it's easy, and then you just transmit close to the demand. So this is a huge potential for Brazil. You can also talk about Porto Alegre. Porto Alegre has a huge demand for electricity. You can also build batteries in Porto Alegre to reduce the transmission from southeast, for example. Nowadays we're having issues with electricity generation in the south. What's the name of the dam? There is the Bento Munhoz, Foz do Areia. It's at 4% of its capacity. It's very low, so it's not operating because it just doesn't have any water anymore, because ONS for some reason decided to use all the energy from the reservoirs in the south. The problem is that the transmission lines, they are limited to something like 8 to 9 gigawatts. But at night, they're not transmitting 8 to 9 gigawatts because there is no demand. But if you had batteries, for example, or pump storage in Porto Alegre during these times where you have a bottleneck, where you cannot transmit more from one region to another, what you can do, you can transmit at night. You don't have demand, but you can store at night. And then you don't need to build new transmission lines between the southeast and the south region. Do you guys have any questions so far? So distribution also, one of the benefits is for distribution, as I mentioned several times, you have the issue in Brazil for peak generation. Peak generation is sometimes in some tariffs 5 to 8 times more expensive than off-peak. And that's because of the cost of the of distribution systems. It doesn't make sense to increase the number of distribution because it's expensive. You just increase a lot the tariff during peak time so that people would stop using energy during peak times, or they will buy diesel generators to supply their demand for peak generation, and then the distribution system becomes much more cheaper, much more efficient and optimized. And an option is to store the energy at night. So you have batteries at night when the distribution system is sleeping, literally. You use it to store energy at your house or in your supermarket, and then during peak times, you just generate energy from the battery. You don't need to generate solar power or wind power or anything. You just buy when it's cheap and you use when it's expensive. But of course, also you can use batteries to store solar power in your house. Any other solution, you can have maybe biomass gasified generation, and you store energy during night when you don't have demand in your power plants, and you use in your industry, and you use during the day when the electricity becomes more expensive. And of course, there is also the smart grid. So use batteries in locations where it makes the distribution system more optimized, in order for people to generate solar power, and then you store it somewhere in your grid, and then you know when you're gonna need, and then you add a new player to your distribution network, adding batteries to optimize the system, reduce the cost of expansion, for example. And another service is auxiliary services, which is literally guaranteed that the frequency of the demander, of the carga, of the power in the grid is 60 hertz. In Brazil, we have 60 hertz frequency to guarantee that the voltage, so the amount of power supplied in the grid, is enough to keep the grid running. For example, you have a blackout, when thermoelectric power plant explodes and stops generating, or a station explodes, fire, you have batteries, you can at least reduce the impact of the impact and find other solutions. While you find all those other solutions, you have batteries to supply your energy needs. Black start is, for example, if you need to start a plant, sometimes you have a generator in order to provide energy to start a coal power plant or other plants. And instead of using generators, diesel generators, you can use a battery as auxiliary services. Electricity for transport, I'm going to talk more details, but the idea, as everyone knows, Tesla has its market shares higher than the 5 or 8 other automotive companies. It's gonna happen. Energy battery cars are becoming a reality in Europe, in the US, in Japan, and the prices are becoming lower. For example, in Norway, if you want to buy a car, the electric cars are cheaper than ICE cars, internal combustion engine cars. There is a lot of move for hydrogen. I'm going to go talk about more details about this in the future, because what's happening is that battery cars are becoming are getting so much investment and attention that the oil sector is going to become irrelevant, because people are going to charge their cars at home. You won't need even petrol stations. So the oil and gas industry realized that if they want to keep using their infrastructure, they need to invest in hydrogen, because it's a fuel. You still need pipelines. You still need fuel stations. Hydrogen has benefits with battery cars because it lasts longer. It's much lighter than batteries. For example, cargo transportation is much better. It's another solution for the electrification of the transport sector. There is a challenge now between Nikola, which is investing in hydrogen trucks, and Tesla, which is investing in battery trucks. Is a irony, I would say, because Nikola Tesla kind of developed the energy infrastructure that we have today nowadays, the AC, alternative current, and which is the base for our energy sector. And they are trying to use their name to sell the company. It's working. So you have proposals for ships running on hydrogen, airplanes running on hydrogen. Airships are going to start becoming viable again because it consumes much less fuel, given that fuel now is an issue, because with hydrogen, fuel is much more expensive than just gas or oil and putting in your tank. You really want to be as efficient as possible. So airships are becoming a big thing. I personally have published like 2 papers on airships. If you guys are interested in airships, I can talk about airships. It's not really energy storage, but it's an interesting topic. You have e-highways, which is literally having electricity, providing power for trucks and highways. You have trains, electric trains all over the world. You have metro, you have trams. So these are already kind of common sense. And if a country wants to go public transport instead of everyone having their own cars, I personally prefer, I lived in Austria, it was great. I loved not having to drive 40 minutes and just work in a very comfortable train. It's also options which I will go through. So hydrogen, compared with all the fuels, is the one that has the highest energy density. It has a much, much higher energy density than the other fuels, actually. Compared with natural gas, it's something like 3 times more energy density. So if you have 1 kilo of hydrogen, you will generate 3 times more energy than if you have 1 kilo of natural gas, regardless if it's liquefied or gas form. It doesn't change the rate. Have liquid fuels. Liquid fuels are good because are convenient because they occupy less volume. Even if you liquefy the hydrogen, which takes a lot of effort, it's very expensive, it's difficult to contain, you're going to be losing hydrogen because it's going to evaporate. And if you, for example, fill up your liquefied energy hydrogen tank, in a week it's all evaporated. You don't have hydrogen anymore, which is a huge issue for hydrogen. You just fill up your tank with diesel and then it's there. And another benefit is that it occupies much less volume, so it's concentrated in volume aspects. It's very interesting. For example, a liquid hydrogen is this similar volume to natural gas, so compressed natural gas, which is this, what we have in cars. In Brazil, we have gas vehicle. We use methane to run cars. So you would need a similar volume. So it's a similar kind of tank that we have to add in the back of the car to provide at 700 bar. It's not convenient to have cars that store liquid hydrogen because it evaporates. And the other solution is batteries. The battery has a huge disadvantage because it's very heavy. So is it something like 50 to 100 times? You need 50 to 100 times more weight of batteries to provide the same energy storage. But the advantage of batteries is that it's more efficient. It's a better option if you use your car just to drive 10 to 20 kilometers per day, because all the equipment that you need to run a liquid hydrogen tank is also heavy, right? So you have to find out optimum equilibrium. We're going to go through this in more detail. So the electrification of the transport sector, this is for the US. There are scenarios that the energy demand for transport will be something like equivalent to the energy demand for industry, residential, and commercial sectors. You have a lot of demands for transport. Usually when you see these primary primary energy graphs, transports take a huge chunk. Why? Because it's inefficient. Because diesel, when you burn diesel, you only use 30% of the energy. When you burn, for example, when you use electricity, the electricity that you're using is 90% efficient. When you use hydrogen, it's something like 40% efficient. Fuel cells are usually 40 to 60%, but you also need to store the hydrogen. You need to convert from AC to DC. You have a lot of other things so it's more efficient to use electricity. So this curve for transport is usually half of the electricity used in the country is for transport. But in this case, this line is going to be smaller because the efficiency. This is the change. This is the change in electricity demand. So there will be a lot more demand for transport sector compared to the increase in other sectors. This is the US. Now I'm going to talk about heating sector. So I'll talk about electricity. I'll talk about transport. Now heating. Also, heating is a huge demand, not in Brazil. In Brazil, only for taking a shower or cooking. But for example, in Scotland, half of the energy is for heating, the other half is transport, and the other half is electricity generation. So a lot of other technologies which can store energy for the future in heating and cooling sectors. Yeah, well, I have 10 minutes. So what I'm going to do, I'm going to start at these alternatives and all these other parts in the next lecture. If you don't mind, it's just that I don't want to rush too much on these aspects. Let's just talk about this in the next lecture. We have 10 minutes. I'm sorry for not planning the time very well. So stopping at the transport sector, do you guys have any questions so far? No questions? Right, so even though we have 10 minutes, I'm gonna go through the homework. I don't wanna take your time, guys, after the lecture finishes. I'm gonna talk about the other topics in another lecture. So the homework, it shouldn't take more than 10 minutes. If you really want to think about it, please feel free to do it. It doesn't need to be to provide this to the next lecture. but at least next week will be interesting to have your feedback. The idea is for you guys to select from 1 to 10 the topics that you guys are interested to hear about energy storage. So if you want to hear more about grid energy storage, off-grid, transport sector, smart grids, demand-side management, computational modeling, long-term energy planning, hourly electricity prices in Brazil, so the PLD, innovation and patents, energy storage economics, energy storage regulation, theoretical focus, if you want me to focus more on the theory, or applied focus, if you want me to talk more about hydrogen pump storage, other energy mechanical energy storage, batteries, hydrogen, thermal energy storages, biomass, biogas, ultracapacitors, fossil fuels, compressed energy storage, cryogenic energy storage. That means liquefying air. And if you have other themes that are not mentioned in this table, please feel free to add them to the table. Maybe I didn't think of all of them. Maybe I'm forgetting something. The other question is, if you want the lecture to be in English or Portuguese, I'm comfortable with either. Please feel free. Let me know. And other tasks. Oh, is to sign the confidentiality agreement that I sent you guys. Please feel free to sign. Please feel free not to sign. Sorry. And do you guys have any questions about this homework?
Yes, Julian. Is there any Excel sheet for we to check this, or we have to write by hand?
No, I'll send you an Excel sheet.
Okay, thanks.
You're welcome. Perfect. Thanks so much. And the conclusions is that the course evaluation criteria is to develop an R&D project. Oh, please, I'm gonna add to this homework to give your comments on the evaluation criteria. This is not set on stone. I can also always change for you guys, make it something more normal, like you usually do. I just thought that it was a bit interesting to have you developing projects that you're actually gonna use. I introduced energy storage, the need for energy storage, why it's so important now, which is literally the increase in renewable energy generation, which doesn't have energy storage into the system. I talked about the transformations of the transport sector, heating sector. I didn't start. I'm going to go through that in the next lecture. And I didn't talk about the other topics because I didn't have time. Sorry. And yeah, thanks so much for your interest in the lecture. I hope I succeeded your expectations. And if I didn't, I'm happy to hear more about your feedbacks. And I'm not sure if I was clear, if you guys understood me. Did you guys understand the English? Do you want me to speak slower, quicker, or it's okay?
For me, it was great. Thank you very much.
Thanks so much, Natalia. Okay, guys, this is it, then. I'm looking forward to your comments and to your inputs, feedback on what you're expecting to hear from me. I'm doing this because I literally haven't done the lectures, so I still have to prepare all the lectures. So I might as well prepare something that is interesting to you. And yeah, it was a great pleasure. My first lecture in my life. So very, very happy. I'm gonna celebrate here. Thanks for your participation, attention, and have a good time.
Thank you.
Thank you, Julian.
Thank you. Bye.
Thank you
Thank
for
you for the
everything.
class.
Bye.
Bye.
Bye-bye, Professor.
Good night.